Ada, hai. Kena patah balik accept pula. Siapa ni? Suresh Rajesh. After 9:30, I tak nak accept lagi lah. Nanti I keluar masuk. Okay, so this one, we already know if let's say you want to send a message to other parties between me and you, let's say, or maybe in one single devices you want to have a communication to each other, which is you need to have a message like instructions or any kind of message between two processes, maybe you need to use MPI data type. So here, this is a comparison table between your MPI basic data type and your C or C++ basic data type. So you normally see all of this like sign char, sign integer long, unsigned char, float, double, because C programming we always use, right? So normally if you want to assign something, maybe I want to assign sign integer, I assign something to it. So this one will be as a sign integer. This is normal C or C++ programming, or maybe there is a float. So you declare something here. So this one is a float type. You will know that, okay, this one is float. This one is sign integer because you already declare. And same goes to MPI. MPI, you need also to declare your data, your whatever data that you have as the input, you need to declare it. And as per similar to C and C++, you can see there is a correlation between each other, only it is different in terms of wording. So if you have float, let's say, you have float in your C or C++, but in MPI, you need to put it as MPI dash float. Dekat C ni dia macam senang sikit, but only the difference, I guess, you need to put all MPI in front. MPI dash something, MPI dash something. So you need to remember all the data type, MPR char, MPI short, MPI int, MPI long. So over here, it is shortest compared to your C or C++ in terms of the int. You didn't see the int over here. If long, unsigned char, unsigned short, unsigned long. If it's called as unsigned, you can see normally it is a char and float over here, and also MPI double. So this, if you want to declare something, you need to use MPI data type only. That is the purpose why you need to learn all of this, because in your programming you need to apply. You need to apply all of this type. Maybe you can just use as your simple source code, and you try to play around with all these basic data type. What will happen to your output? If float, if double, what is going to be happen to your output? And here, as I mentioned, you're going to learn categories of communication. How you going to communicate between two processes or two parties in your MPI. So you can see over here there is two main categories, which is point-to-point and also collective communication. What is point-to-point communication, how it's look like, and also collective communication. Now we're going to go one by one. I guess it's not too hard, only that it's kind of boring because yeah, it's just a reading and also it's just a theory. Throughout, you need to understand it. For here, this is point-to-point communication. Communication between two processes, one to one, which is, let's say you have a processor 1 and processors 2, you will be having direct communication. There is no just any entities, any process in between. Tak ada langsung. So there is no interruption between, which is direct communication or point to point. Both processes are in a same communicator. That's why you have the same environment and also same communicator. Sender will maybe your P1 is as a sender and also your P2 as a receiver. You need to define sender and receiver. Who are a sender, who are a receiver, will be identified by their rank. This rank you already learned in your previous subtopic, previous topic, module 5. So you can see over here, if you have two processes, you will use point-to-point communication if you need direct communication between these two processes. But of course, in terms of instruction, let's say you have one single instruction here, you will see that of course you're going to have a receiver and sender. Same goes to us in our daily life. Tak ada tiba-tiba dua-dua jadi sender in one time. Tak ada dua-dua jadi receiver in one time. It must be have one sender, one receiver in one particular time. But maybe in what you have, let's say at 10 a.m. At 10 a.m., this will be a sender and this will be a receiver. Maybe at 11 a.m., this will be a receiver, this will be a sender. If you want to declare like this also can, it's depend on you, because programming you can play around any kind of task that you want to. You can create any kind of program, right? So how you're going to define and declare them as a sender or receiver is going to be identified by their rank. So you can also set up them. In terms of point-to-point communication, you're going to see there are also two types of communication, which is synchronized and unsynchronized, blocking and non-blocking. I guess when COVID arrived, you always see this kind of word for your class. Okay, class, today we're going to have synchronized class. Okay, this one we're going to have a lab and synchronized. I guess you will heard from your lecturer whether you have a synchronized or asynchronized class. So same goes to your communication. In your communication also you have synchronized and asynchronized, same in your daily life, in your class and etc., or maybe your task. You will see that now what will happen in our Gmeet session, Google Meet. We have a synchronized communication. because we are communicate right now in a real time directly. If you want to communicate to me now, I also can communicate with you in our synchronized class. But let's say for your lab, I give you a task. Okay, this source code I want you to use and to do as your lab 2. So this one is example. So please do it and submit it to me through your e-learning. So you can see I give you a task and I want you to give me back the feedback. So this is as instruction. In class, maybe I will ask you and you will revert back to me. I ask you a question, simultaneously you can answer it to me. But unsynchronized, when I give you a question, maybe you open it at 10 a.m. Maybe also, I don't know that you open it at 11 a.m. But what happened here in synchronized? Now it's happening, let's say 9 a.m. All of you are hearing my voice and my task I give you at 9 a.m. synchronously. You get my message through here. But when you have unsynchronized, maybe you have also a delay, maybe you did not open it. So in any time you can open. Maybe you can open also at 10 p.m. So it is not synchronized. You open it on different time. And when you want to revert it back to me also, it is depend on you what time you want to revert back. But synchronized like this time, we have two-way communication and you will revert back to me directly. So that is about our daily life, which is on the class. Later on, you will see some example. And how about blocking and non-blocking? We look into first, which is synchronized and unsynchronized. So here, what is the example given in our slide? In our slide, the example are showing as a asynchronous communication when sender may send without knowing when the message will be received or read by the receiver. Same goes to me. I give you a task for your lab too. I don't know when you open it. When you do it, I don't know, isn't it? So without knowing. Receiver does not know also, receiver does not know when the message was sent. You basically don't know what time, specific time maybe when I send the message. Same goes to your e-learning. I upload it, the file itself, this file. So you don't know what time I uploaded the message when I send the message to you. So in terms of email nowadays, of course you will see there is a time, there is also a date. So you know it, but it's still also unsynchronized when you can basically open whenever you want. Only that it have an improvement in terms of detail when the email are coming in, what date, what time. Sometimes your sender send to you at 10:01 minutes, but you receive the email, there is a delay, maybe 10:03. Sometimes I said to you, I already sent the email. Do you get it? No, no. Okay, refresh until several time of refresh. Then you said, oh, I already get that email. So this is unsynchronized also. Right. Okay, so we're going to continue. So how about synchronize? Synchronize is much more easier because we know basically when. We know when the receiver receive our message because we are directly communicate. Receiver also know when the sender send the message. Of course, you know because it is direct communication, right? So it's called as a synchronized communication. Now you can see the differentiation between synchronized communication and unsynchronized communication. We're going to look into blocking and non-blocking. What is basically blocking and what is non-blocking? Oh, hey, what happened? Okay. So blocking communication operation. The process is blocked until the communication operation has complete. So let's say, I give you example, a simple example about laundry. You can see when you are doing a laundry at your Dobby, you will use your washing machine first. Washing machine, after you finish wash, then you're going to use your dryer, isn't it? This is washing machine, this is dryer. So if you did not complete wash your clothes here, you cannot move to dryer. Then you need to wait until your washing machine is finished. Then you can move to dryer, which is the process is blocked. You block this process because you need to wait until your washing machine finish first, then you can proceed to dryer. While non-blocking communication, a process may continue with next instruction without waiting the communication operation has complete. Okay, let's say I give you similar. Let's say similar thing. Maybe in term of your washing machine, maybe you have advanced machines. You can also have the washing machine with the dryer. So in term of your process, you will just continues your dryer while you also do the washing. I don't know whether it is possible or not, but I just give you an example what happened in a laundry situation. So if normal laundry, you can see it's a blocking, which is blocking communication. You cannot continue while you wash, you cannot do the dryer. This is the example of blocking communication. While continuous, maybe, okay, I give you example, maybe in our situation currently. We have Gaza, which is Palestine, and also our Israel. Okay, they are bombing to each other. Bomb. So Gaza can bomb Israel. Israel can bomb Gaza while they are bombing each other. It is non-blocking communication. Tak ada siapa yang block. Tak ada Gaza boleh block, send and bomb Israel only after bombing several times and they stop. Then Israel can continue. It is not just way communication, right? So you can see there is a total difference between blocking communication and non-blocking communication. And you can see the unblock process can always find out the status of non-blocking operation using test and wait function. So you can see later on you will use the test and wait function just to see what is the status. So there is a PS over here. Notes for you. All non-blocking operation should have matching wait operation because some system cannot free resources until wait operation has been cancelled. So let's say you have a long of instruction in your source code. Maybe this one you want to send it as a non-blocking. But throughout, maybe some part of this process over here maybe cannot free the resources because this maybe use your register EAX. If you still remember on your register, maybe this one also using a SAM register or maybe SAM processor. While these instructions are execute, maybe you are doing this line and because it's a non-blocking, you are doing it all together parallelly. And this one, this instruction need to wait this certain specific instruction because you are using a similar and refer to your similar register. You need to wait until this line finish first. Then you can proceed to here. But if you are doing this line, you can always do it parallelly. Here can do parallelly with here, which is non-blocking. That is why all non-blocking operations should have matching wait operation as to know that some of the instruction or some of the operation cannot free the resources. What is your resources? Sometimes you need to find and link to your resources until wait operation have been cancelled or finished, right? So that is about your communication, synchronized, unsynchronized, blocking and non-blocking. Later on you will need to use all this communication in terms of your programming. Okay, now point to point mode. What is your MPI communication function? Just in point to point. So you can see there is a several that you can use. First like INT MPI as send. You can put the voice buff and INT. This is a blocking operation. Although, let's say you have point to point and another one your collective communications. So over here you can have a blocking and non-blocking. Same goes to your communications of collective communication. You can have blocking and non-blocking. Whether you can also have synchronized and unsynchronized, similar to here. So you can have both particular communication type also. So in here, if you are using this command, if you are using this command, it is a blocking operation. It is a synchronized send. So there is a synchronized send over here. Synchronized send. Message goes directly to receiver process, which is direct. As I mentioned, if synchronized, it is a direct communication, and point to point also it's direct. Oops, sorry. Only complete when receiving operation has begun. So it is blocked because you need to wait. You need to wait until certain process complete first. Then you will move to next. So under MPI B send, you can see it is a non-blocking operation, which is buffer send. It is unsynchronized. So you need to know. Let's say you were given only a instruction. Please create or please write an programming to use a point-to-point communication, synchronized and it blocking. Then you know, oh, this is the command. Same goes to this one, and etc. So you need to know all the functions of the commands on of the source code that available. So under INTMPI send, which is unsynchronized. Message is copied into a buffer which is provided by the application. With MPI buffer attached, like this one, void, buff, integer size, always complete irrespective of receiver. So it is a non-blocking operation. While there is another one is INTMPI send. This is blocking and non-blocking operation. See, you have both in one. Standard send, which is synchronized and unsynchronized. You can have both, whether it is synchronized or unsynchronized or blocking and non-blocking. If you just use this one, maybe I give you a hint, maybe you don't know and you forgot how and what command to use using synchronize. So you just assume use this command, then because this one can be applied for both. That's why it is a standard send. How are you going to send your message, right? How are you going to send a message to P2 from P1? So you just use in INT MPI send. So you already instruct to send it, but your program here, your instruction here can be whether it is synchronized or unsynchronized. And you can also have INT MPI resend. This one is you are ready to send, which is non-blocking operation. Assume that receiver is ready, which is your P2 maybe at that time is ready. Always completes irrespective of whether the receiver was ready or not. So it is a non-blocking operation. And another one is MPI receive or MPI RECV. it is a blocking operation only when complete, then message only complete when message has arrived. So you will see when you can use in your source code. Let's say over here you are applying these two. This is a normal standard. You can use this and this. Sorry, this one and this one. Receive, send, and also receive. Then you can see you're going to use your MPI send and MPI receive. You have all the library, your declarations, and later on you will see how you instruct your instruction to send the message. So you can see MPI send, and then you have numbers, which is you declare the numbers, and then 1 MPI I need 1 0 MPI. This is must. If you still remember last our module, you must to put this MPI world in every single declaration or process you are using. You can see you need to use all in all. You must have MPI world as the environment. If you still remember MPI world, what is it for? And you can see over here, it is when you want to declare it as a send. So it will send. And you will declare another one is MPI receive. So you're going to have a receive instruction over here. So there is an exercise and also solution. Please try to do it. You already given with the source of your code, source code over here. Please try to run it. Okay. The question: write and program that implements the flow of event as follow. So basically, in your programming test, you're going to have a programming test, right? So it will just give you some instruction and details what are needed in your programming, in your source code. Same goes to your final assessment. You are going to give with a task, what is detailed in each several tasks. So this is similar also, but of course this one is very short, just an example of your exercise. So we look into, there are two processes. So of course you're going to see, okay, you have two processes. Example as P1 and P2. That's why you need to create first. So you need to create two processes. One will be as a send and one will be a receive. So you can see over here, it is sending. Let me check first the instruction. P1 requests the user to type in two integer values, which is x and y example, and send the value to P2. So you can see P1 will be as a sender at this point, and P2 will be a receiver at this instruction or this task. And then what is your P2 will do? P2 will solve the equation, which is total up the x plus y. Because P1 will send x and then it will send y. So when P2 receive, you will need to create in your P2 to be doing the operation adding between these two data that sent by your P1, and return the value to P1. What is meaning by return back? So if you look, you can also have uh, P2 to be as a sender and P1 to be as a receiver at this point, because you need to return back. P1 display, mean printf and so on, display the value of your total, which is you adding this one on the screen. So let's take a look over here. So you have two values. One of the values, which is the one that you will key in, you will declare the values, which is whether it is X and Y. So you need to scan F, whatever you key in. So this is the value of your integer, Y, X, Y. And of course, when you add these two integer numbers, you're going to have total. So this one should be also declared as int. So you already declare first. And then you need to know, you need to have several tasks. Your P1. Your P1 over here is RO, is okay. RO and R1 will send X and will send Y value. It will be a sender. So over here, MPI send X, MPI send Y. You need to see the declaration. You also need to have the MPI world. So this is the rank. So you can see what is the rank. First, you're going to send the X and then the Y value. And your R2 will be a receiver, MPI receive. And after you receive, you're going to total up, isn't it? So total, you're going to see that you will see the ranking over there. You're going to total up ranking 1 and ranking 2. And you still have the similar environment, MPI world. After you already total your ranking 0 and 1, which is receive the send X and Y, you're going to total and also print. So you can see over here, you're going to print it. You're going to see also, you will have the ignorance. So this is done, you already create, and this is also already done. And this and this. And you can see, if your word rank is 0, then you will do it all. But maybe if, let's say, you have an error, which is your word rank is equal to 1, you're going to have the MPI receive, which is X, 1, X also 1, and you have the ranking over here. You have the status ignore. You're going to total up X plus Y. So MPI will be sent back to the R0, the total, and it will give you the total up to be print. So over here you can see you receive, you will send, you send, and then your processor will receive. And then you can see After that, you're going to revert back the MPI sent to the RO as a total. So you're going to send the total to the RO, and RO will receive and print it out as a total. So this is example of the source code. You can try it and see what is the output that you will receive. Okay, then you're going to learn wildcarding. What is wildcarding? Receiver may also receive message from any process or any message. So you have a several processor here. Processor 1, 2, 3, 4, and 5. So to receive any source, you can use this MPI any source. To receive message with any tag, you can use MPI any tag as over here. Let's say MPI receive or MPI any source. But of course, you in this task, you're going to use only two, right? And receiver process may find out the actual source and also tag of the communication from MPI status. So if you want to check about the source, you can check the status and parameter of MPI receive function. So you can see over here, let's say under processor 5. If you just use this MPI any source, so processor 1 can send, processor 3 can send. But you don't know who are your sender. If you want to check, you're going to use the MPI status to check from which source. And also you can also check it by using MPI receive function. And this is under wildcarding because you know that wildcard is basically you will randomly you will send, isn't it? Informations in MPI status, which is your data type. If you want to check, you're going to use MPI status. Now you go deeper to your MPI status to check what is basically your MPI status and how you're going to use this MPI status to see which resources you are coming from and so on. Under status, MPI source, hold the rank of the sender. So you can see MPI source, you have the rank of your sender, which is your source ID. Process of the communication. So then if you have this status MPI source, you can see the rank or the source ID of your sender. Under status again, status.mpi tag, call the tag. For source, you hold the rank, but this one is holding the tag number of the communication. Example, in the C code, you can see it's print source equal to this one and tag equal to this one. So in your MPI, you're going to put it status MPI source. So this one is your from source and status MPI tag. So this is example how you can use to write and use it in your MPI using C code. Measure program execution duration. How measure your duration and the finish time using your double MPI W time void. Beginning until finish. So here is the example of how you're going to apply your code, which is you're going to have your start MPI time and also your finish. You're going to also stamp the finish MPI all time. You can see if you have the
It's 10 hours.
and 11 I got class. Okay, you can see over here, if let's say you have several processor like P1, P2, P3, P4. In using a wildcarding, you are allowed to receive any kind of a processor data. You can receive, this is using a wildcarding, right? You can receive any kind of data from P1, P2, and P3. But if you have using the deadlock, you can only receive or send two specific processor. If you already assign it like this, which is P1 will send to P2, P2 will send to P3, P3 will send to P4, it is a deadlock. You are the one that will set it. Not like the wildcarding, you can receive from any, but you are the one also will assign that. So if it under non-blocking communication, phases in non-blocking communication, initiate non-blocking communication working on other operation. Wait for non-blocking communication to complete. So this is the phase under non-blocking. First, you're going to initiate it. Second, you're going to working on the other operation. And third is you're going to wait for non-blocking communication to complete. So if let's say you have the point-to-point and non-blocking communication modes, what commands that you're going to use? If it is standard send, what is the command that you will use? If it is synchronized send, what will you use? Similar to all these table back, you can see this one. This is point-to-point MPI functions, and this one is specifically, although it is point-to-point, but it is only for non-blocking. So you have several standard send, synchronized send, buffer send, ready send, and receive. So it quite different to your previous one. You can see over here. If you have a receive MPI RECV, but this one is also receive, but you will declare it as a non-blocking. Send and receive message. The basic function for sending and receiving message are MPI send. This one we already looked at the table. This is the standard how you're going to send and how you're going to receive. MPI send the data stored in a buffer or in your stack. MPI receive a message sent by another processor. It will return to the sender only after the message have been received and copy into a buffer. So this is the differentiation between MPI send and MPI receive. Previously, you are still looking on non-blocking operation. For non-blocking communication operation is accomplished by using the MPI send and MPI I receive function. The MPI I receive function does not take a status argument to blocking receive function. The status information associated with the receive operation is written by MPI test and MPI wait function. Now you're going to look into deeper MPI test, MPI wait, what is basically happen and how you're going to apply it in your source code. We look first the wait function. To wait one or many non-blocking communication to complete, you use the int MPI wait. And you can also see that you will have the MPI request, MPI status. If you want to wait all also, you can using the int MPI wait all. Or others, you can use the wait any and wait some. So you can see you have several wait all, any, or some. It is still under your wait functions for your non-blocking communication. And now you look into the test. For test, it is to test the completions of one or many non-blocking communication, whether your instructions, let's say already finished or not. You just want to test, to check whether you have a complete or not. In int test, you're going to see also you have the test any. One is test and also test some, and supposedly it will be test all, but this one is MPI with all. I guess this one is an error. Flag is Boolean variable, which is flag true means that the communication have complete. So if you check the flag is true, which is normally it's 1, right? Your flag, if the your output is 1, it means that it's already complete. So it's depend on you how you're going to see the test of your communication. Now you're going to see the point-to-point, which is non-blocking communication mode. Uses example of your send. You can see you have the send, receive, send rank, and receive rank. This is the usage example, how you're going to use all the sending, all the receives and receive data, rank, and so on to be in terms of your command. If you have the MPI status, send status, you're going to send. You can also receive the status to check your status whether it complete or not. And you can also request, send a request when a finish, and so on. So this is example. You can copy it paste, but of course you need to have the library, you need to have the declaration. Same goes to here, you need to have end of all the process. Then you can try to run it. What is happen when you are using MPI send or MPI receive? So this is in a C programming. If you have, let's say you swap this one to be rank 1, this one is to be rank 0. What do you see to all of this? You're going to receive first, then second you're going to send, isn't it? It's depend on your rank. If you have another rank, it's going to be like, this is going to do first, this is going to do second, this is going to do third, and so on, because you are declaring the rank. So please try to do all this example. You just need to copy it first, copy paste it back and see it basically what is different. Because over here you are using MPI send and MPI receive, but what has happened when you have the value of, if you have a command, wait, okay, if you have a command using MPI send, I send, and MPI I receive. If you look back, it is the purpose for you to use the, where is it? Okay, this one is send and receive example. You can see this is the mainly point to point. But if you want to have the non-blocking, where is it? Example. Okay. If you have the non-blocking, you're going to use this IR send and IR receive. That's why I want you to check the differentiation when you use MPI send and MPI I send and receive. What we're going to happen, because this one is non-blocking. You can have this as a rank and you can do it parallelly. The variable request is used in the MPI wait function to determine the status of operations. So this one is under MPI wait. So you're going to see the status of your operation, what is happening at that time. And there is an exercise 2. Please do it. Later on, I will assign it to be your next lab. We already do lab 1 and lab 2, right? Maybe this one will be a lab 3. Later on, I will inform it back. So there is a several other, but I don't want to finish it. But only few left. It's okay, I will continue until we finish our module 6, because after we finish the theory, we can go and try take a look into all the programming. You can see over here, we're going to try it and run it into our Ubuntu, our MPI. So this one, as I mentioned, I'm going to tell you and inform you later on whether I'm going to use it as a test, a lab 3 or not. I will copy and paste, or maybe I will edit some of these detail for you to create your own programming. Okay, now we're going to look into after you already done. Previously, you are looking point to point communication. Now we're going to move to collective communications. And all our cognitive communications and computation operation, what is basically happen? If all processes that belong to wait, okay, sorry, I have an instructions from the coordinator. Okay, now we're going to look into our collective communication. Previously, we already done on our point to point. If all processes that belong to communicator participates in an operations, all of them must call the collective communication function. So over here, the keywords is in an operation, all of them must call the collective communication functions. If the processes that belong to communicator participate in any operation. So example over here, you have several MPI collective communication function will be discussed is MPI barrier, MPI broadcast, because MPI reduce, scan, gather, chatters, all to all. And you will see also the detail what is the function. Okay, some of the question maybe if you have the multiple choice, it's easy for you. Maybe you were given the command, the source code. What is this function? Where these functions apply? Whether it MPI barrier is a point-to-point or collective communication. So you need to memorize all under collective communication. This is the one, the functions that available. If under point-to-point, what is normally you will see like MPI send, MPI receive. So that is on point-to-point. So please take a look into what is the detail and functions under all the in our collective. So you can see over here, collective function. You have like the broadcast. You can see over here. And then MPI reduce, MPI or reduce, MPI scan, MPI scatters, gather, all to all, reduce chatter. This is all collective function communication. So you can see how your communication will be look like if you are using a broadcast, chatters, gathers, all gathers, all to all, and etc. You can see it in a figure showing here. So what is the function? Barrier, MPI barrier. The barrier synchronized operation is performed using your MPI barrier function. MPI barrier, which is MPI com. The only arguments of MPI barrier is the communicator of processes that will be synchronized. The call to the function written only after. So means that after all process have done in a group have called this function, then you can use these functions of your MPI barrier, MPI com. For broadcast, the one to all broadcast operation is performed by MPI bcast functions. So this is the example how you can apply these broadcast functions. MPI bcast send the data store in your buffer of the source process to all other processes in group. Same goes to WhatsApp. You have the function to broadcast a message, right? Same goes to here. This is similar function. You're going to broadcast to all in the group only. If you did not save the numbers of a particular person, you cannot send the broadcast message to them, isn't it? goes to your MPI collective, you will only send to broadcast in the group. And then under MPI bcast broadcast.c, you can see this one is the example of how you're going to use your bcast collective functions. Later on, we will try to run it in our Ubuntu. And you're going to see also the output. What happened? Wait.
Doktor, saya nak tanya.
Maybe you can just interrupt me and use your microphone rather than
Tak betul, sorry doktor. Saya nak tanya, yang
Yeah.
kan doktor tunjukkan MPI bcast.c tu kan?
Kejap ya.
So memang kita wajib pakai
Hello?
MPI apa? Hello? Okay. Internet habis tu.
Ya, ya.
Ya doktor. Kan kat MPI bcast tu, memang kita perlu pakai MPI, memang kita perlu startkan dengan MPI init, MPI comsas and MPI comrank untuk kita punya programming. Betul tak doktor?
Yang ini
Bcast. Ampun.
Yang ini? This one?
Yang tu MPI init, MPI comsas dengan MPI comrank.
Wait,
Is it we need to use it? Adakah itu memang template dia doktor? Memang kita kena letak waktu kita nak buat MPI.
This one? This one is your declaration. This one is your declaration first about your process. Then you memang kena ada macam if you learn your COA subject before this, you have the template right before you use the assembly language.
Yes sir.
So first declaration of your dot data delay ke ni? So this is the declaration. So you can see over here.
Okay doktor, nampak.
You going to declare it first. Okay. And if you see, you can see all of these also having your environment. This one is the environment that you're going to use.
Oh, I see. Okay doktor.
Okay, I continue.
Thank you doktor.
Okay. Sorry, I guess delay kot. Sebabnya saya bercakap dengan you bertindih. So, okay. We move to our reduction. So, if there is any question, you can just interrupt me. So, to all, one reduction operation is performed using the MPI reduce function. So all of this, we're going to try to look the coding and we're going to run it into our Ubuntu later on. But today we're going to see only on the theory part. So our MPI reduce it in your programming. And MPI reduce, what is the functions is it's going to combine the element of store in your send buff, in your buffer send of each process in the group using the operation specified in ops and return to combine value in your receive buff, which is your buffer. You can have the send and also receive buffer right of it. In terms of you have the reductions of your MPI, you will also have the MPI ops, which is a set of predefined operations. It is a short form I. So there is a lot of other choices that you can use. Normally, you can see this is a a digital logic gates or the functions, apply it using your collective communicator function. All of these function over here, you will see what is the purpose and what is this task. When, if let's say there is a task for you to create using the XO, then you're going to use the MPI BXO. Or maybe it's not directly mentioned like this. Maybe you just said you have two integer X and Y. You need to have the output of your total with value of 1 if your X and Y value is similar. Dia pusing-pusing macam tu, your instruction is quite confused. But basically, if you see, oh, this is kind of an operation. So you can use this function, which is your BAND MPI band, or it is a bitwise AND, and so on. There is a lot of it, but basically it's normally you will use like sum, minimum, maximum, location node, product. So not all you're going to always use, but the most that you're going to use is like a sum, minimum, maximum, and product. So over here is the example for the MPI reduce source code. So you can see over here, we will try to run this code and we're going to look into one by one what is the meaning of all the functions and codes inside. But basically, if you see, there is also a command for you, comment for you to see what is basically the code and functions operation. It is for process to look first also. And this is the output, example of the output. So we're not going to look it by today, because today we're going to proceed with our theory first. Okay, now we have, and still under collective communication, we have the prefix. The prefix sum operation is performed using MPI scan. So you're going to scan, you're going to use MPI scan for you to use the prefix. This is example how you're going to declare and write inside your programming. MPI scan, what is the functions? It's going to perform a prefix reduction stored in your sandbox. Each process and return back the result. You can see you're going to return the result in the buffer receive path, or your receive buffer. The receive buffer of the process with the rank I, it depends whether it is rank 0, rank 1, rank 2, and etc. will store at the end of the operations the reductions of your send buffer of the process, which is whose rank range from 0 to I. I is the maximum number of range that available. If 2, then it's going to be 2. Another one is on your scatter. This operation performed by your MPI scatter function. How are you going to apply it? in your source code. So what is the function? It's going to process the send, a different part of send buffer, which is send buffer, to each process including. So you can see it going to send, but it going to send include. I give you example P1, P2, P3. Okay, it will send to P2 and P3, but it also will send to itself. The data that receive are stored in your receive buff. So all the data will be stored in your stack of your receive buff. Process sending the value of 10, it will store inside your receive buff. So process I receive send count contiguous element starting from I, send count then to send buff from the process source process. So it must, this one, it must call by all processes with the same value for send count, send data type, receive count, receive data type, source, and com. If you have these all function, you're going to use this I scatter. And we have gather. Gather functions is to process, include the target process, send the data store in the array send buff. You can see it send the data and store in array send buff. All of it having a different way it's going to store. Like your scatter, it's going to store in your receive buff, but in your gather, going to put and store in your array send buff to the target process. If let's say you have P number of processor, you have maybe 5 processor in your communications the target process receive of total P buffer. So you need to have you need to have 7 buffers. The data is stored in array receive buff later on of target processor in the rank order. So you're going to have you're going to organize it in a rank. So maybe you're going to store 0 and then 1, different kind of function. Maybe it store 1 and then 0 and then 3 is depend on how you're going to assume it. And another function under collective communication, this one is you normally use your MPI all to all. Because you can see that if you have the processor 1 and processor 2, 3, you can send it to, oh sorry, okay, you can have this P1 to P2 and P3, and P1 also can send to P1, P2 can send to P1, P3 also can send to P1, and P2 can send P3, P3 can send to P2. So it is all. Each process send different portion of send buff array and also include itself, also it's include also itself. So it is like a logic diagram, and you can see each process send send count contiguous elements starting from the I, send count location of its sending instruction. Each process receives ref count element from process I and store them in receive path. So you can see you're going to store it in an array of receive path starting at the locations of I. So this function MPI all to all must call this same value of functions. It's quite similar to your scatter. Sorry, saya tak perasan. It is at our last pages basically. Okay, I'm going to finish it first. Then I need to stop the class also because after this I have another direct class. Okay, we continue first. Tiba-tiba terkeluar. Saya pun pelik kenapa tiba-tiba gelap ni. Baik. Okay. Okay, you can see over here, if let's say we have the functions of all to all. So each process is quite similar as I mentioned, it's quite similar, but sometimes you will see what is the process that you need to use. What process you need to call to use the MPI all. with the same value for, let's say, receive send count, send data type, receive count, and receive data type, and lastly your com. Of course, this one is connected to your com world. Then we already cover all. Next week, what we're going to do before next week, as I mentioned, very tasty. Example, okay, 5.2. As I mentioned, maybe I'm going to give it as a lab 3. We already done lab 1, lab 2, lab 3. Then I think I'm going to change a little bit over here. What is the instruction that I want to use? And I assume it as a lab. Later on, I will inform you. And next week, we're going to do all the MPI broadcast and then MPI reduce. We're going to try to apply it into our Ubuntu. So please make sure you prepare with your computer. You open your Ubuntu and we're going to play around with our MPI. Is it okay or not? So is there any question?
Doctor.
Yes.
For the lab 2, when is the deadline for lab 2?
I guess inside your e-learning I already put. I also forgot.
There's no submission link, Doctor.
Huh?
There's no
Oh,
submission link in
for
e-learning.
your
Second lab.
maybe, I forgot to make the link. But for your SECR section 1, let me check. Because your due date with the another section is different. When I scroll down. Oh, I not yet created the link. By today, I will create the link for you, and I think I'm going to give until this end of this week, until Saturday. Is it okay or not?
Okay, Doctor. Thank you.
Okay, thank you too. Okay, any other question?
I'm sorry, but the submission link for the lab 2 and 3 are in the same week or different?
Lab 1, we already finished on the submission. The due date is already passed. But for lab 2, I'm not yet created, so I'm going to give until Saturday midnight, 23:55, which is until before your Sunday 000 time. And for lab 3, I'm not yet decided. So it's going to be 1 week after I give normally. So if I give you tomorrow, then it's going to be 1 week after that. Okay. So any other question? So if there is no question, I will upload our recording into your e-learning, so you can always refer it back later on, okay? So thank you, and don't forget to scan your QR code. I already upload the QR code into your e-learning. So hope that everything is okay.